My name is Keith Potter, and I'm the general manager here at Silt Saver. We manufacture performance-based sediment control products, and today we're here to talk about our signature product, the Silt Saver Dome. We actually make 5 different versions of the dome, and all 5 are based upon the concept of two-stage stormwater flow. Before we start, I'd like to ask you which of these methods could save you more than $100,000 over your next 10 projects. In this webinar, I want to challenge you to think about the true cost of protecting stormwater inlets on your construction projects. By applying some data from an actual project we recently worked on, we'll use a simple Excel model to compare the cost of the 3 most common types of inlet protection that we see used today. Those are the traditional silt fence box, the rock and wire inlet, and the rigid filter inlet, of which the Silt Saver Dome is one example. While our Excel model captures many of the costs for most projects, there are costs that would be very difficult to accurately estimate in this simple model. These costs can be substantial for a given project based upon the location, scope, and environmental sensitivity. For example, silt fence boxes are known to require frequent maintenance and are prone to failure. Repeated failures or having to clean out the stormwater system before the project will be accepted by the owner or regulator can involve substantial time and money. We've heard from several clients about the time and difficulty of removing the wire and stone from rock and wire inlets. Something we learned on this project is the productivity loss associated with rework due to obstructions around the inlet. This requires the contractor to install their finished surface and come back to remove the inlet protection. Once the inlet protection is removed, they have to excavate around the inlet and do a second pour in order to complete installation adjacent to the inlet. You can imagine the cost of this rework being significant over a large project. So let me introduce you to the model. The yellow highlighted fields can be edited to input material and labor costs for your specific project. These cost and man-hour estimates were provided by the engineer we worked with on this specific project. This project involved the use of our new adaptable dome, which has been designed to fit the South Carolina DOT Type 25 inlet. In many cases, these Type 25 inlets are installed side by side with a common top. During construction, we refer to these as double barrel inlets, where you have 2 openings versus 1 larger opening on a common precast top. Here's an overview of the entire model showing all 3 methods and the costs for labor and materials of each. Now we'll zoom in on the analysis of method 1. We estimated a total of 4 labor man-hours and 1 operator man-hour in order to trench, drive the post, attach the fabric to the post, backfill, and compact the earth around the silt fence at each location. In this case, the installation cycles per project, or the total number of times that the silt fence must be removed, a new silt fence box installed, was 2. In this case, the engineer stated this would happen at least twice. On some projects, this can happen 3 or more times during the project life cycle. We can put that into the estimate to make it more accurate. This does not account for any maintenance or failures, which everyone in the industry knows are common for the silt fence box BMP method. The total project cost for the silt fence box on this 1 double barrel inlet was $1,159 per location. The second method we looked at is the hardware cloth and stone inlet filter. This BMP is much more difficult to install, and the performance is very much dependent upon the installer. You can see there's a lot of potential for variability with trenching of the fabric, installation of the post, spacing of the post, and most importantly is the amount of stone and the height of the stone that they install. You can see that there's a lot of variability even in this one. While not as prone to complete failure as a silt fence box, installation and maintenance have a big impact on how this BMP performs. The common concern with this method is how costly and time-consuming removal can be, as well as the rework due to obstructions around the inlet requiring the second pour in order to get the final surface to grade. Much more substantial BMP, but quite costly and complicated. The engineer estimated 6 labor man-hours and 2 heavy equipment man-hours, 2 changes in grade that will require demolition and installation of a new inlet filter. The material cost for this method is more substantial than the silt fence box, as well as the removal cost. This method is estimated to cost over $2,000 per location. Based upon feedback from the engineer, their actual costs were slightly higher than that. In some cases, he estimated up to $2,200 per location. Finally, we look at the rigid inlet filter. In this case, we're showing the new Silt Saver A700 adaptable dome. It's a smaller rectangular version of the larger round or square frame and filter that has been used for many years. As I mentioned previously, this specific device is sized to fit the South Carolina Type 25 inlet or similar designs of smaller inlet opening sizes. Unlike the previous two methods, the rigid inlet filter relies on the reusable frame for easy installation and consistent results, and that also simplifies removal and reinstallation. As you can see, the cost of this method involves much less labor and more initial material cost. Even considering the purchase of 2 domes for the double barrel inlet, the overall project cost is still lower at $937 versus the other 2 methods. So I told you we'd talk about extrapolating the comparison to multiple project costs. This is where I think you can really capitalize and benefit from the rigid frame and filter method. Not many of the materials can be reused from the first 2 methods, maybe some of the steel post, but the rigid frames can be reused literally hundreds of times, and the life of the filters can be extended depending on the severity of conditions and the duration of the project. So if you extrapolate the cost over 10 projects, the cost for the first 2 methods does not change much. The cost per installation stays pretty much the same. However, for the rigid filter, we assume that we change filters every other installation, which is conservative because the filters may actually last much longer. You can see this drops the cost from $937 per inlet to $537 per inlet on subsequent projects. Using the same method for the silt fence box and the hardware cloth and stone, we can extrapolate those costs over 10 projects to be $11,140 and $19,710 respectively. So when you compare that cost over 10 projects, there's a savings of over $5,000 versus the traditional silt fence box and almost $14,000 versus the hardware cloth and stone. For demonstration purposes, we assumed a typical project has 20 inlets. Some projects we know will have fewer, while linear projects may have hundreds. If you multiply the per inlet savings by 20 inlets per project, you can see how the rigid frame and filter saves over $100,000 versus the silt fence box and over $250,000 versus the cloth and stone method. So I hope this webinar helps quantify the true cost of the inlet protection and provide data to support using a BMP that is easier to install and maintain, performs better to control sediment, which is what this whole industry is about, and saves significant cost over multiple project cycles. Send me an email to keith@siltsaver.com or call the office to learn more about our inlet protection solutions. I can also send you a copy of the calculator so you can do your own comparison. Well, I hope this webinar causes you to think differently about how you design and estimate inlet protection on your projects. Please give us a call and we can talk about your sediment control challenges. And stay tuned for the next webinar in our series where we'll talk in more detail about the cost comparison calculator. Thanks again for listening.